Okay, so normally this would be an investigation that we would do in class, but obviously we can't, so I'm going to work through this investigation. Now, it says graph each of the following, and it gives you 3 equations there. So what I'm going to do is I'm going to fill in this table of values first. -3 squared, so y1 will be this first graph. This is y1, this is y2, y3, and y4. So y1 is just the squared graph, okay? So it looks like this. Now I'm going to put my scale on this graph so it fits this graph specifically, and we'll work the other graphs around this one. All right, and then going up, just so that we don't have so much writing, I'm just going to do every other box as 2. Okay, so now when I graph this again, start at 0, 0, over 1 up 1, over 2 up 4, over 3 up 9. The other side, over 1 up 1, 2 up 4, 3 up 9. Connect the dots, and it should be nice and round. It shouldn't be pointed. Put arrows on the end and you're done. Okay, the next graph, we're going to take all of those values from the first one, and really all we're doing is we're timesing them by 4. Okay, because it's 4 times x squared. So 36, 16, 4, 0, 4, 16, 36. Now on this graph, the only points that are going to fit are the 4s, because everything else is bigger. But what that means is that I can't get to that next line until I'm at 16. So I shouldn't let my graph actually get to that next line. Okay, so it should never get to that 2, because 2 would have to be at 16. All right, now the next one, we're going back. So we're always working back to that first y squared, the black graph. Okay, so the next one, we're multiplying all of those y values by a half. So 9 times a half, 4 times a half, 1 times a half. So we're going to have 4.5, 2, 0.5. Notice how everything is going to have 0. And this one, we can fit everything on the graph kind of nicely. Okay, so this one, we're going to have 3 and 4.5, 2 and 2, 1 and a half. We've got our 0. And it looks something like that. It's nice and round, like a cup. And we put our arrows and we're all done. And then last but not least, we're only going to be able to fit a couple here, but we're going to have 12 times 9. So we're multiplying by 9, or sorry, by 12 this time. So 12 times 9 is 108. And we've got 36, and we have 12, 0, 12. And notice how they're the exact same on both sides. Okay, so the only one we can fit is 1 and -1 and 12. Going all the way back down to 0 and all the way up. Throw the arrows on the end, because our next point would be 2 and 36, and we clearly can't fit that. All right, so go back to black here. Compare the y values with the notes. What I'm actually going to do is we're just going to summarize all of this at once. Okay, so the bigger the y value, or sorry, the bigger the a value, because these are all a values, which is the number in front. So the larger the a value, the more narrow the graph is. And the smaller, and we'll summarize it a little bit more later. The A value, the wider the graph is. Okay, this A value here is bigger than 1. This A value is between 0 and 1. Okay, that's just equal to and greater than. So the first one is bigger than 1. The other one is between 0 and 1, or greater than 1 and between 0 and 1. Okay, so the next page here, all we're doing is we still have that first graph, which is the y squared. So get -2, -4, 2, 4, 2, 4, -2, -4, -6, -8, -10, -12, -14. Now I'm just going to graph 5 points this time for x squared. So 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. Now what I'm going to do is I'm going to just take my points and I'm going to multiply them by the value in front of the A. So I would do this as my y value for the second one, the green graph there. Take 1 and multiply it by -3, and I get -3. Okay, I'm going to take 4 and multiply it by -3, and I get -12. Same thing on the other side. All I'm doing is multiplying the y value by these numbers. Okay, that's my graph. Okay, same thing for the next one. I'm going to take all of those values. I'm going to have 1 times -0.2 would be -0.2. It's right in here. 4 times -0.2 is going to be 0.8, but it's also going to be negative, so it's actually going to be kind of right in there. Not even quite at -1 yet, so the graph's going to look something like that. We again still have 0, 0. And then the last graph, the -10, same thing. Oh, I've already got green. Blue. That is blue. 1 becomes -10. And we can't do the next one because it would be -40, so we'll just do 10. We'll go like that. So, to summarize, when the A value is negative, the graph opens down. So all that we have to look at with the A value is the A value is negative. If it's negative or positive, that tells us if it opens up or down. All the other rules still apply. You notice that when it was a big A value, the 10, it was very narrow. When it was a little A value, the 0.2, it was very wide. The positive and negative just tells us which way it opens. So write an equation of a graph that opens up, y equals 3x squared. One that opens down, y equals -x squared. Okay, it could have been anything. We just needed to put a negative number. All right, the next one here. So I'll just move this down a little bit. The next one, we've got 0.1, 0.05, and 0.6. So all we're going to notice here with this one is that as we have those decimals, so I'm going to draw on that first one, and then I'm not going to use the actual numbers. I'm just going to show you what it kind of looks like, and we'll assume everything is just a box of 1 here. Okay, so because when we're looking at this, 0.6 is the greatest. Okay, then we have 0.1 and then 0.05. So 0.6 might be something like this. Okay, that would be 0.6. It's going to be wider than my first graph, but not by a whole lot. Now the next one we said was 0.1. Okay, because it's smaller than 0.6, but it's bigger than 0.05. So that one looks something like this. And then finally, just moving across here, this one would look something like that. Okay, it's just going to keep getting wider and wider as the number gets smaller and smaller. But as long as it's still positive, we're still going to have that graph that's moving up. Okay. To summarize, so the summary is going to be on this next page here. Okay. For what values of a is it narrower than x squared? This is when a is equal to, or sorry, when a is greater than 1. So any value greater than 1. And remember, it doesn't matter if it's positive or negative. Okay, because the positive or negative just flips the graph. And then this one is any value between 0 and 1. Okay, write an equation for a parabola that is narrower and opens up. Okay, so it's going to be positive, and it's got to be narrower, so it just has to be a number bigger than 1. Okay, vertically stretched and opens down, so it's narrower, but it opens down. So now we just need to put a negative number and a number bigger than 1. Okay, now compressed means it's wider, opening up. And then compressed and opening down would be negative 0.8. Okay. Okay, moving along. Okay, so now we've got a k value. K values are actually very easy. Again, I'm going to put this on here. Okay, which is just our normal x squared graph. The k value, we're looking at this because we're still just looking at y. So we've got x squared plus 1. So all we're doing is 0 plus 1 is 0. Or sorry, is positive 1. 1 plus 1 is 2. 1 plus 1 is 2. 4 plus 1 is 5. And 5. So this graph has just moved up 1. This one is x squared minus 5. Well, what we're doing is we're taking 5 away. 1, 2, 3, 4, 5. We're taking 5 away from each point. So this one's moved down 5. Okay. So the k value, now I'm going to just write this as one kind of big thing here. The k value moves the graph up or down. So the k value in this equation is positive 1. K value in this equation is negative 5. It moves the graph up or down. If it's positive, it goes up. If it's negative, it goes down. So describe the position of a k value of y equals x squared to the x-axis when k is positive. It's above the x-axis. It's moved up. It's below or on. Okay, so y equals x squared starts on the x-axis. Y equals x squared plus 3 starts above the x-axis. Y equals x squared minus 6 starts below the x-axis. It's moving it up or down based on that k value. Okay, write an equation of a new parabola that is translated above the x-axis. So we need to have a k value that's greater than 1. Any number greater than 0, any number bigger than 0. Okay, now below the x-axis, it's just got to be any number that's, oh, and I messed up there, any number that's less than 0. Okay, and on the x-axis. Okay, it can't have a k value. The k value has to be 0. So now we need to write an equation that's vertically stretched, opens up, and the vertex is 4 units below the x-axis. Okay, so if it's opening up, that's a positive a. It's stretched, so it's got to be a number bigger than 1, and it's moved down 4, so we've got -4. Now we're vertically compressed, opening down, and the vertex is 2 units up. Well, first, it's opening down, tells me that it's negative. It's compressed, so it's got to be any number between 0 and 1. And then it's moving down 2. And then finally, it's stretched and opening down. Again, opening down is going to be negative. Stretched is any number bigger than 1, 1.5. And it's starting on the origin, so it hasn't moved up or down, so we don't have to put